All right. Hello, testing, testing, testing. Hello. All right. Welcome, everybody. My name is Jose Anunciato, and I believe we're all here for web dev, right? We're all in the right place. Yeah, so we'll be together for the next 13, 14 weeks, learning all about web development. It's really just learning how to code. We just happen to be using web-related technologies. So we'll be applying everything you've been learning in many other courses, all the techniques that you might already be familiar with. But we just happen to be building stuff using the web as the infrastructure, right? And all the different quirks and things you need to consider when you have multiple computers talking to each other asynchronously and sharing data across the World Wide Web, and interacting with remote databases and remote servers, spread out over a several geographic area, and so all the different challenges that go along with that, right? And so a lot of the things that you already know, we're just going to be reusing that, just applying it to this particular problem, right? Of coding to the World Wide Web. So there are several sections that are going to be sharing the same syllabus, the same piazza, the same material. So there's a couple of undergrad courses as well as a couple of graduate courses that are sharing some of the same material. So you'll see some questions go on piazza that have to deal with perhaps a particular section. I'll make the best to make sure that if there's a specific message for a specific section, I'll add it to the title, right? So that you can easily just ignore it. I'll create folders that are specific to different sections. But most everything that questions that people are going to be asking are going to be relevant to all sections, right? So please, just keep an eye on what folks are asking, since it might be relevant to you. We are going to be meeting Mondays and Wednesdays at 2:50. So today is this week is kind of like a half week. So a lot of the material that we're going to cover today is going to spill over to next week. But it's fine because it's a first week. We have to set up development environments. It's one of the more painful weeks since everybody has a little bit different setup, different operating systems, so the TAs are gonna help us through this a couple of painful weeks as we install the node server, the databases, the various tools, right, and get everybody up to speed so we have a full working environment. Yes. There's plenty of TAs that are going to be helping us, and they've listed here all their availabilities when we're going to be running different office hours, right? And try to encourage folks to also cover some of the weekends, since I'm sure you might use those weekends to catch up, and also since the assignments are due on Mondays. I'm guessing there'll be a few folks who need help that weekend. Also, Mondays get very, very busy since the due date is that midnight. So we'll try to help you and support you on Mondays. But yeah, so they're providing links to either Zoom or Teams, right? So you can join their office hours. So please make sure that to go and use those resources. There are students that have taken the course before, have been TAs for perhaps several semesters. So they already, I'm sure they'll have lots of wisdom to share with you, and they should be able to get you out of a rut, right, to get you going. So please use those resources. Agenda, it's a very busy agenda. There's a lot of material to cover. We are going to be talking about clients and servers and databases and how to integrate all those three different tiers. And there's a lot of material, a lot of homework to cover. So please stay on top of the assignments and the due dates. And don't, if you need help, try to ask for it as early as possible. Don't leave it to the end. You have other courses that I'm competing against and for your time and attention, but please stay on top of this. So yeah, so there's so let's see. So there are going to be about 6 big topics that we're going to be covering. Broken up into 6 distinct assignments, right? And the first one is we're going to be learning how to create user interfaces, right, using just plain old HTML, right? We'll learn how to use a browser, right, to just render all sorts of different layouts, forms, interactions with users. It's going to be all static at first, just to learn how to just lay out the screen and whatnot. The second part is going to be geared towards how do we make it look a little more presentable, a little more professional, just clean it up a little bit so that we can change the look and feel to be responsive, right? So that it can be used not only on large desktop monitors, but also on smaller laptops or even an iPad or even on a phone, right? So how is it that we design our user interfaces so that it's useful across multiple devices, right? So I'm going to spend a couple of weeks just talking on how is it that we can, with the same source code, right, make it available and useful on any number of devices, right? So that's going to be the first couple of assignments. Then we're going to be focusing more on the dynamic part. So how do we make our applications dynamic, right, data driven, right? So that instead of be hard coding a lot of this source code, how can I compute the output, right? Perhaps by having data stored as an XML file or as a JSON file, or me going out to some third-party API, IMDb or Amazon or Yelp or any of these free third-party APIs. How do I can retrieve that data, right, and dynamically render my user interface, driven by this data that I can go and fetch, right? Also, how is it that I interact with users as they click and drag and type and enter data with our application, right, the state of the application changes over time, right, as users interact with the application. So how do we, how do we render, or how do we update the user interface, right, as the state of the application changes over time? Yes. So for that, we're going to be introducing JavaScript, and in particular, the React library that is going to allow us to render this data dynamically, right? So then we're going to continue some more on the same topic of React, but introduce some things that we're going to be losing, right, as we're going to abandon plain old HTML and move towards the dynamic rendering. We're going to be losing a few things, such as navigation, right? The standard way of navigating between multiple screens is that you have hyperlinks, right? You click a hyperlink and then it navigates from one screen to the other screen, right? So that's old school. That's the way we used to do it, several decades ago. So by having our user interfaces dynamically rendered, we kind of lose that. So how do we recover that feature, right? Being able to navigate, and so we'll introduce single page applications. Also introduce how to navigate using our React routers, as well as how to maintain state of an application, right? It's easy to maintain state in a single little screen or a single little component, but what about applications that go across the entire application, right? Who's logged in, or preferences, or things that mean something across an entire application, right? So that becomes much more complex, right? So we need to be able to share data across the application, and events that get generated, in one particular part of the application needs to be, shared or broadcasted, right, to other portions of the application that might be interested in that same events, right? So how do we share data that goes across multiple pieces of the application? So we'll introduce Redux and reducers to be able to do that. So that this is more or less the halfway point of the course, and so for there we'll have our first exam. For exams, typically by then you'll probably have had several quizzes. More or less every week there should be a quiz, except the first week. The week 0 and week 1 there won't be a quiz, but the quiz 1 will be, and 2 will be the second and fourth week. And usually my quizzes are all online. They're on Canvas. They're self-grading. They usually take about 20-30 minutes, and it's either multiple choice or fill in the blanks. Usually I give you a snippet of code, and then ask you, right, fill in the blanks so that the code does something, right? I explain what the behavior of the code is, what it should do, right? And you have to fill in the blanks so that the code does what I ask you to do, right? And the exam is basically a very long quiz, right? It's just the same material that we've covered for the last couple of assignments, and so the exam 1 will be all the material between HTML, CSS, JavaScript, React, routing, right, up to that point, right? So the first exam is there. Usually we do a review right before the exam, where we go over sample questions from prior exams, right? And we solve it here together in class. I give you a PDF that has all those questions. We go over together, and the exam is not too far off from what I share with you, right? It's just it'll be a randomly. My exams are usually randomly generated. So you'll see a lot of gibberish, variable names or function names that you really have to read through them to understand what it's doing. If I used correct names and reasonable names, the code would be trivial. You would know exactly what it's doing. You wouldn't have to think about it. But since I use gibberish names, you actually have to step through it and understand what it's doing, right, and figure it out what I'm asking you to do. So that's this week number 7. We'll do the first exam. So this ends the first half of the semester, which focuses mostly on the user interface part, right? And mostly on the browser rendering a user interface, either static or dynamic or reacting to user input, things like that. The second half of the semester, starting on week 8, focuses mostly on the server side, right? Where we're going to be able to escape some of the limitations that we're going to have on the client side, on the browser. Applications that run on the browser are limited by what the browser can do, right? Browsers, for security purposes, don't allow you to do certain things. Don't allow applications to do certain things, like, for instance, access a file system, right? Or make a unfettered network access to anywhere you want. So for security purposes, right, when you download an application that runs in the browser, it's caged in, right? It's running inside of a secure little box that it can't do certain things, right? It can render beautifully, right? It can respond to user interface input and whatnot, right? But it can't save stuff permanently. So usually web applications rely on some server support, right, for all the things that the browser can't do, right? So we have to create a server, right? In this case, we're going to create a node server that can serve as a complement to our user interface, right? So now the user interface is going to generate events, right, that are not going to only be handled by the user interface running in the browser, but it's going to also send data over to the server saying, hey, they're added so many items to a cart, right? Or they're created a brand new post, right? So all this needs to be sent over to the server, and the server can then either save it to a file or save it to a database, right? Or make network connections to all sorts of other resources, right, that would not otherwise be available from the user interface browser. Yes, right. So the server is going to provide a support, right, to our user interface, right. So we're going to create our own server from scratch, and also learn how to maintain state on the server. How people can log in, right, and provide an identity, right, and then we can be able to not track them in a malice way, but maintain a session, right, so that they can establish a conversation, right, a discussion, right, with the server, right, back and forth, right, because servers are usually serve multiple clients, right. You can have dozens, hundreds of these applications running on the browsers talking to just one single server, right, and the server needs to be able to multitask, right, and maintain multiple conversations simultaneously, right? It needs to be able to distinguish, who am I talking to, right? And the way it does that is by maintaining a session, right? Saying, okay, well, it's you again, right? And so I'll show you your cart, right? But if it's you, I'll show you your cart. It's different, right? You have your products and you have your products, and I have to be able to maintain a session that's by user. So we'll learn how to log in, register, maintain a profile and whatnot. So we'll talk about that here. We also need to be learning how to store data permanently, right? Up to this point, all the data that we've been generating and reading, it'll be temporary. It'll be transient data, right? We won't have a place to store it physically permanently. And for that, we're going to be adding the capability of talking to or integrating with a database. We're going to be using MongoDB. It's a non-relational database, very, very popular, which is going to allow us to provide a permanent storage solution to our application. Okay, we're going to be generating data from the client, sending it to the server, and then the server is going to be saving it to the database, and vice versa. We're going to be retrieving data from the client. We're going to retrieve data from the server. The server is going to fetch it from the database and send it back to the client for rendering. Yes, right. So it is a multi-tiered application, right? You have the user interface tier, right? They have the middle tier server, right? And you have the database back in the back end storing this data. Make sense, right? So that's more or less a set of topics and skill set that we're going to be learning this semester. The last couple of weeks are we're going to work on a project right? Or I'm going to demo how you would put all these skills together to build something from scratch, right? I'm going to choose a third-party API. I'm going to grab the Napster API, right? That allows you to fetch songs and album art and about different artists and whatnot, genre. And I'm going to build a little application around that, right? A little kind of like a little social network application where people can log in, search their songs and or leave a review for a particular album, right? And people can find other people that like the same genre or the same band or album, right? And they can have a conversation, follow each other, and share some social interaction amongst themselves, right? Now, up to this point, right, up to week 10, all the assignments that up to that point, we're going to be building something together, right? We're going to be building the Canvas application. It's based on a very popular learning management system that sounds similar, but it's not. So we're going to be building something that looks like this. We're going to be starting with the first assignment. We'll build a few things. We'll build the home screen. We'll build the assignments that list the various assignments that you can see the grades, that you can see your account and profile, that you can log in and change your first name, phone number and whatnot. So we're going to be building all these little screens that are going to be trying to recreate some of the behaviors of the Canvas application, right? And we're going to be doing this throughout the next 6 assignments, right? In the first assignment, we'll just do plain HTML, right? Let's create a few screens. Let's learn how to navigate between the screens, right? We'll do some hyperlinks that allow us to go between the multiple pages, right? And learning about how to create forms like this, right? How to go to how to create tables, right? How to create lists that contain multiple sub lists. So we'll have an opportunity to learn about how is it that you use just plain old HTML to do this, right? Then in the second assignment, we're going to say, well, it looks horrible, right? From the first assignment, there's no, it doesn't look anything like this. All right, so we'll come back on the second assignment and we'll paint it a little bit, right? We'll add some color, some background, change some of the fonts, some of the layout, right? And also we'll learn how to implement things that are responsive. Responsive meaning that as the screen becomes smaller and smaller, right? The application needs to adapt, right? So, ooh, I'm too small, right? I can't fit that last column, right? So, well, maybe that last column is not as important, so I'll just drop it, right? Just to give more space to something that is more relevant, right? And as it gets smaller and smaller and smaller, right? Again, it makes the same decisions of drop maybe a few other things, right? And move a few things out of the way so that you can still see the main content, right? So this application is useful not only on large monitors but also on smaller laptops or iPads or even a phone. Yes. So that's what we're going to be doing. So in the second assignment, learning how to make things that are responsive, useful across multiple devices. At first, the first assignment will be static. All this content will be static, right? And then we'll start learning on the third assignment. Well, all this data must come from somewhere, right? Usually there'll be some database that I'm hitting, right? Depending on the course that I'm looking at, the section that I'm looking at, right? Who I'm logged in as a faculty or as a student, right? And so some third-party API will come back with the data, and then this will be rendered dynamically, right? Where I iterate over multiple modules, right? Where I'm showing several modules here, right? And each module has multiple pieces of content, right? So I iterate over the modules. Each module has a whole bunch of links in there, and I iterate over this huge JSON object, right? That will dynamically render this content. So that's what we're going to be learning on the third assignment, right? And then as we go, we're learn more about as I log in, how do I share data across multiple courses? How do I navigate and things like that, right? Yes, makes sense. So that's what we're going to be doing the first 6 assignments. Building something like this, right? So by the end of the 6th assignment, hopefully you'll feel confident enough to say, okay, well, I can build anything, right? And so the project, now the assignments are all individual, right? So each one of you is going to build the same exact thing, right? We're going to handhold you through the whole process, right? First, we're going to go through certain set of skills, right? That we all need to learn. You're going to get a chance to then apply those skills to build this particular application across 6 assignments, right? And the intent is that by the end of 6 assignments, you'll feel confident enough to, in a small team, decide, hey, let's build something, right? And so that final project is, you as a team deciding, what is that you want to build, all right? There's certain requirements, right? But in general, you should be able to build anything you want, right? It's just keep it PG-13, and decide that together with a team of between 1 and 5, decide what you want to build, all right? Yeah, and that's due at the end of the semester. So the last couple of weeks, I will demo, right, building one of these projects from scratch, right? And then the last week, the project is due December 4th. So soon after you come back from Thanksgiving. And there'll be demos, right? You'll demo this to your TA, right? And basically they're going to go through a list, right, which is available here, I believe. There's a checklist. So they're going to use this checklist, to ask you. They're going to ask you. Oh, I need to fill it out. Anyway, they're going to ask you, hey, show me that your application does this, right? Show me that I can do that. That you can log in, that you can register, that you can go to a profile, that you can see your personal information, that you can edit your personal information. Okay, that you can. You have to choose some third-party API where you can retrieve data, right? That you can interact with that data, you can retrieve data, you can display that data, that you can create new data, that you can create relationships between data, right? So there's some set of generic requirements that apply to all projects, yes. And so the TA is going to go through that list, which you will know what it is, and please demo this, that, and the other. Okay, they're not going to try and crash your application. They're not going to try and trick you into you breaking something. You'll be prepared for your demo, right? Because you'll know exactly what you need to demo, right? You'll know exactly the requirements, and you'll have a scripted demo for the TAs, right? That demonstrate each one of those requirements. Make sense? Right. So soon after that, we'll have the final exam. Again, we'll have a review where we'll go over the previous exam, and we'll see some sample questions. And the exam will be soon after. I believe for graduates, undergraduates have asked for a date, that I don't know yet. They're going to assign to us a particular room and a particular day. I'm not quite sure when that is. As I know what it is, I'll let you know, right? And I'll update these. For graduate students, I think it's like the last day of class, right? Yeah, let's see. Evaluations. So assignments are 40%. So there's 6 assignments, 40% of the whole grade. The quizzes is about 10%. The project is 30%, and then each exam is 10%. Right. These are the grade letters. Late submission policy. So the policy for being late is that it's easy. You can be as late as you want. You'll just lose 1 point for every hour that you're late, right? So all my assignments are due, I think, on Monday at midnight, right? If you think you need a couple more hours, you don't have to ask for permission. You just, if you think you're not going to make the midnight and you need, to finish up at 2 or 3 in the morning, you'll just lose 3 points, right? Or how many hours you missed that deadline. All right, so it's easy. Obviously, if you're 100 hours late, then you lose all the points. Quizzes, blah, 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 project, right. So projects are between 1 and 5 people can be in a team. You'll need to create a team in Canvas and invite your team members to join that team. Now in the list, in the checklist at the end of the semester that you fill out, it will ask you, right, what are the team members of your team, and which section you're in, right? So if you want to work with other students that are in a different section, it's okay. It's just more work for us to be able to know that the grade has to be the same across multiple sections, but it's fine. If you have other buddies that you feel more comfortable working with another section, that's fine. Just jot it down. If you do join a graduate level section, that the requirements are slightly different for the graduate students. It's much more they're more challenging for the graduate students. So the requirements would be of the graduate students, right? So if you join an undergraduate, then the requirements are for an undergraduate course, which are slightly easier than the graduate level students. I think 5 people is way too much. I think the ideal team size is between 2 and 3 students would be plenty. I've seen that bigger teams tend to not work very well. Of coordinating folks and sharing source code and sharing across a Git repository, and some folks go MIA, right, and don't contribute as much, right, and they tend to be a drama at the end of the semester with the larger teams. And please, I'd rather not avoid that drama. Join large teams if you really trust those other folks. Okay, don't just join any old random team. I think you'll regret it. It always ends up sometimes people just fighting and saying, "Oh, this guy never did any work. I did the whole thing. I'm worried about my grade." Okay, so it has happened to me oftentimes. It's usually this happens like at the very last week when there's nothing I can do. Right? If you do this very early, or much earlier, and maybe we can do something about it. But usually all this drama happens, right before you submit the project, and there's nothing I can do about it, right? So I want to discourage you from joining large teams, especially if they're strangers that you can't trust. I don't know. Only join large teams that you can trust. Academic integrity. A lot of the source code is available online. Certainly, I've been doing this for a while, and there's repositories from previous semesters. Please avoid looking at anybody else's source code, right? Especially copying source code from anybody else. Ideally, any material that you submit, right, is legit yours, right, that you have created. TAs have been around the course for several semesters, so they are familiar with other students that have submitted material from prior semesters. So just don't copy anything from prior semester. They're aware of things that they have graded from prior semesters. You're welcome to use all the source code that I provide. Right, I'm going to do a lot of the grunt work of setting you up with each assignment. I will demo each assignment, right, and I will submit all this source code in source control, right, and I'll share the Git repository with you. So feel free to copy anything from my source repository. Okay, that's fine, just not anyone else's. Right, just stick to what I gave you in your work. Okay, I mean, it's fine if you're discussing with other folks and whatnot about general questions. That's fine. Also, it's fine if you find general solutions out there in Stack Overflow or even ChatGPT, right? But just don't try to fool us saying that it's yours, right? If you got something from somewhere and it's not totally relevant on what we're asking you to do, that's fine. right? That you use source code from here and there, snippets from here and there. Just be honest about it. Says, this is not mine. I got this from ChatGPT, blah, blah, blah. It's a function that does this, right? And that's totally fine. But if it's something that we ask you to do, please, have it be your work, okay? What else? Please feel free to interrupt me if you don't understand something, or please come to my office hours. If my timing office hours doesn't work for you, let me know. Just and we can set up a different time to meet. I know undergrads have a tough schedule. Oftentimes you have way too many credits. Yes. Yeah. Hand raise, please. Yep. Let's see what else. I think that's it. If you have a disability, reach out to me and I'll set you, up whatever you need. All right. Okay. Any questions so far? All right. So this first resource module, right, gives you access to the syllabus. Also, the undergrad calendar is slightly different than the graduate calendar, but it's available there with the various holidays. Office hours, we're going to put a map there with all our office hours in there. Piazza, please feel free to reach out to us. Piazza, there's always going to be somebody, right, listening to questions on Piazza. So we're trying to very responsive there. The project requirements, I'm going to go over the project requirements a little later in the semester. Not quite yet. I will be sharing my source code that we're going to be starting today. Right, I'll share in my repository here. There is a required textbook, and let's take a look at this week. So this week we're just going to be introducing the course. There is some reading for the first couple of chapters, and we're going to be learning how to get started on creating our very first web application. Right, so we're going to download Node.js. We're going to install it locally on our machines. Maybe you already have it. If it's an older version, you might want to upgrade it to a later, more recent version. And just to talk about what is web development in general, right, and get us going, getting started with the first assignment. All right, what is web development? All right, so what is web development? Yeah, so first of all, what is the web, right? So the web turns out to be just a large set of computers that are connected, from multiple smaller networks, right? That might be for particular institutions, right? That were originally intended to survive a presumable World War III, right? We coming out from the Second World War. Right, people were asking, how did we beat the Germans, right? And it says, well, we bombed the heck out of them, right? And we destroyed their ways of communicating through, by land, by telecommunication. And they said, well, could this happen to us? So there was a lot of research in the '60s on saying, well, how would we survive how would we maintain communication, right? If we were ever invaded and whatnot, just in the scale of what happened in World War II. And so there was a lot of research on creating heavily redundant telecommunications, right, where there would be no central point of failure that you can just take out, right, and then all of a sudden we have no way of communicating amongst ourselves, right? So it started by doing a lot of research on smaller Defense Department institutions, right, that sending small telecommunications within a room, within multiple buildings, right, and it just grew into multiple branches of the Defense Department, right, and slowly started to bring in academia and just open up in bigger institutions, even research institutions across in Europe, right, and other places of the world, and seeing how does this all works, right? So, and this all happened in the 60s, right, and a lot of funding by the military, and in the 90s they started saying, okay, well, how folks started saying, well, would this have a commercial application, right? And obviously back then nobody thought of what could you possibly use this for, right? And so in the 90s, folks started experimenting of what could we do with it. Right around the same time, researchers at or in particular Tim Berners-Lee in the late 80s, early 90s, very innocently wanted to be able to share his research results with fellow researchers, right? And says, "Ooh, I want to be able to, instead of just publishing a research paper, it would be cool if I had it in such a way that I could very easily just send you a link, all right, and then you could just see my research paper with images and tables and abstracts and references, right? So all by himself, very innocently, he invented the World Wide Web, right? He came up with the foundational technology, HTML, the browser, the servers, right, the protocol, just as a side a project, right, to share his research findings with other fellow physicists, right, at CERN. Right? And all by himself, he came up with the first browser, the idea of a URL, right, to point to multiple documents and images and whatnot, right, and be able to interact with pages that will allow you to navigate to other research papers, right? So if you've seen research papers, usually they have a lot of references to other research papers, right? That says, oh, these are my conclusions, yada yada yada, and I'm basing everything based on these other research papers, right? That you can. And so he wanted a way for you to easily just click on the text, and it would navigate you to a different research paper, so you can quickly compare these papers, right? So he created the hyperlinks, right, anchors that allow you to go through there. Now, there's an interesting set of events that occurred from the 1960s and how it has evolved over time, right? First the invention of this internet, which is just multiple networks connected over, this hierarchical, small little hierarchical networks that connect to one another into an ever-growing, more complex set of machines that talk to one another. Came up with the idea of the client-server architecture, right? That originally it was based on, it was very expensive to have very powerful computers, and usually you have these, monolithic, huge, very powerful machine that needed a lot of attention and a lot of care, and you had it, in a separate room with air conditioning, right? And then everybody else had this little rinky-dinky clients, right, with green phosphorus CRT monitors, right, where you would type at these terminals, right? The communication would go out to this centralized powerful machine, and then the results would come back, and then you would render it on a screen. So this architecture today is actually more relevant than ever. So it has stuck around for several decades, right, across centuries. So, but it was developed in the 1970s based on a completely different problem they were trying to solve, right? But today, it's funny that we're still very well in using the same architecture, where you have a browser, right, that goes out to the Amazon servers or the Googles or Facebooks of all these centralized server machines, but now these are farms, right? These are computer farms that thousands, millions of these computers that are working together, that are computing something, and then it sends back the response to you, right? Which it's a cheap way of sharing supercomputer power with millions of people or billions of people, where you use the supercomputer power only for a small fraction, right, of milliseconds, right, that computes something that's very, very complex, like you say, hey Siri, right, play whatever, right, and so somebody has to compute that, right? So there's a very powerful machine that's doing this for a very small fraction of milliseconds, right? Comes back with the results, and then that same server is being used by billions of people, right? That are requests are coming and going. So it's the same. This architecture is still very, very relevant today. Now with the advent of, in the 80s with Apple and IBM getting into this personal computer war, right? Of kind of going away from this client server architecture, where now Siri, ignore me. Where now the machines were, instead of being these rinky-dinky small little clients, now start to become more and more powerful, right? Things that now you can actually take your computer into a desktop, right, into your own office, and it can run independently of outside help from these powerful centralized computers. Yes, right. And now obviously this kind of changed the model of how is it that you share software, right? How you distribute software. It used to be that we have these dumb terminals, and all the software was just in this one centralized computer, right? There was very little that was installed on a little tiny terminal. Yes. So it must have been dozens, hundreds of us using the same server, right? But now the software was now installed on my desktop, right? So now you have to. We came up with floppy disks, right, and CDs and all this. Now you have to mail or all this software to these millions of people that have to install it on their local machines, right? That runs on your local machine. So the distribution of the software kind of changed, right, quite a bit. And now in the 90s, we kind of went backwards, right? Where now instead of us installing everything on our machines, we can actually connect again into a centralized computer that has a server that we access things through a browser. So we can kind of like a pendulum, right? It was client server in the old days, became personal computers, right? In the 80s, and then kind of went backwards, where the browser being our client, our dump terminal, becomes our browser, right? That now relies on some centralized server, right? For email, for whatever, right? But now obviously our computers are much more powerful. They have 3D, right? They have all sorts of very fast computers that can render all sorts of things real quick, right? And so in the 2000s, we realized that this was an infrastructure, right? Brand new infrastructure, right? Where applications were now kind of running a little bit on the browser, a little bit on the server, right? Accessing databases, and they were kind of distributed geographically, where you could have the browser running on the East Coast, the server running on the West Coast, and the database running in Europe somewhere, right? So where your application was now geographically distributed, accessing all sorts of resources across the world. Okay, and now developers say, well, how do we synchronize all these things, right? Where you have all this data just going everywhere, right? And that's what we're going to be learning in this class, right? Where now these applications are spread out over multiple servers and whatnot, talking to one another, right? And today, in the 2010s, right? We've been abandoning the desktops and whatnot for mobile computers, right? Where we have phones. Everybody's got a phone in their pockets, and it's the fastest growing demographics of folks who are using web applications are folks that have a phone, right? So now the design of applications need to be focused more on this ever growing demographics, right? That most people access web applications, on a smaller, tiny little screen, right? So you have to design it with that in mind, right? So you can't assume that they will have this huge monitor. You have to say, okay, well, how can I be economical about what am I ever going to show on a tiny little screen, right? What's next? Who knows, right? Are we going to be connected through Neuralink, and phones would go away, and we're just going to have it right to our brains and connected anywhere in the world, even in the middle of the desert or in the middle of the ocean? And are we? Are our jobs going to go away, right? We have a ChatGPT. We have to now compete with with all these AI folks, right? Where I see it as a means that increases our productivity, right? Where ever more we're going to be asked to be much more productive, right? And obviously as a IT professional, we've always been looking to automate our processes, right? We're always been working our way out of our own jobs, right? Where we create ever more powerful tools, right, that can automate whatever we do, right? The scripts that we write, right? The bash files that we write, the cron jobs, everything that gets automated, so that we can focus on something ever more complex. Yes, and that's now that's just being multiplied by thousands, millions, right? Where now we are going to be expected to code not just for us, but dozens of developers, right? We together with AI, we're going to become so much more productive, right? Where we're coding for dozens, hundreds. We'll be our own developer team, right? And embrace this new challenge and very exciting new world. All right. So what's the internet? You have all these networks that are connected to one another, that through clients that are interacting with users, talk to the clients through a server goes out and talks to other servers, right, and retrieves the data and shows it to our particular client, right? So this is what we're going to be spending our time. Now, if you drill down into a particular network, we're going to be building something like this. We're going to be focusing the first half of the semester exclusively here on the client, right? Things that are going to be running on a browser, right? Where we're going to be only going out to the server to fetch some static content, either HTML or JavaScript, only to render the user interface, right? That's all the server is going to do. In the second half of the semester, we'll focus on building on that server, where now not only we're going to be fetching static HTML or static JavaScript, but also for data. We're going to go ask for data from the server. We're going to be posting data, putting data, deleting data, right? Doing all the CRUD, create, read, update, delete applications, and then we'll add the database to be able to make those changes permanent on using a non-relational database, Mongo. Okay, so this is the architecture of what we're going to be building this semester. Okay, a few interesting history of how the internet has evolved over time. On the server side, it used to be that when Tim Berners-Lee came up with the web, the idea of the web, he was mostly just focusing on static content, right? He wanted to introduce his paper, right? His methodology, his conclusions, whatnot, right? And tables and pictures and whatnot. Now, when this became available to a broader audience, people were pushing the limits of what could be done, right? And then say, oh, it's static. What if I want to do something dynamic, like I don't know, something that does the weather? The weather changes over time. How can I compute the content, right? So it can't be always sunny or always rainy, right? So I need to be able to somehow calculate the output and change it over time. So that's where Common Gateway Interface came out, where instead of fetching a static HTML ASCII file, that ASCII text could be dynamically generated, computed, right? And the first implementations were based on Perl or C++, right? Where server, when you go fetch for an HTML document, a static file, actually you executed some code, right? And that code generated a dynamic piece of text, right? That was HTML. It was just HTML, but instead of being static HTML, it was dynamic text that was generated on the fly. Yes, right? By either doing some computation, going out to some network connections and whatnot. So that was the basis. And then in the mid 90s, right? PHP took this idea and says, oh, right, let's write it, let's create this in such a way that you can embed HTML and your favorite programming language together, right? So you can dynamically generate this content. As this evolved, there were certain best practices that were identified, right, over time. So it's okay, well, how do you build these things? What is the correct way of building these things? Okay. And so, and this, like many other skills that in software engineering, we have design patterns, right? We have come up with design patterns that are best practices. What engineers, having been solving problems over time, they've seen that there's a pattern. Oh, these tends to work. This tends to not work. We'll keep the things that work and we'll abandon the things that don't work, right? And we call those design patterns, right? Design patterns have been around for thousands of years in other industries, right? Like in civil engineering, right? In chemical engineering, mechanical engineering, right? Things that in architecture, right? Things that we've been building buildings for quite a while, right? And people have figured out how to build bridges and buildings and whatnot, yes? And so folks have been sharing their wisdom, for the next generations, yes? Same thing in computer science, right? But we're a little bit younger industry, yes? And so these design patterns are the wisdom of engineers that have come before us, right? That come up with these best practices. And so one of those first capturing of the best practices in web development, came to be in the Java 2 Enterprise Edition, right? Where they came up with a set of structured ways of building large web applications, right? They came up with, for instance, the model view controller design pattern, right? That if you're building a large application, it's best to think of these large applications into 3 buckets, right? That try to solve very distinct issues, right? The view bucket, means that, everything that you have to think of interacting with a human user, right? You have to look pretty, you have to have colors, and you have to have images and buttons and forms for you to fill out, yes? And it has to be readable, it has to be nice and formatted, right? Users like to see things organized, yes? And so all the issues that go with the view, right, go in that bucket, or interacting with a human user, right? Then view model view controller. The controller is handling the events that users generate, right? As the user interacts with the application, they click and drag and type and generate a stream of events. Yes? Well, somebody has to handle that, right? And so all the responsibility of handling all these events is the controller. The controller is responsible for receiving from the view, right? As users interact with the view, as they drag and type and and click and whatnot, they generate a stream of events, and the controller takes all this stream of events and creates a data structure out of it, right? A formal representation of the data that is being generated by the human user, yes? And then the model is the formal storage of this data, right? Either in a file or a database, right? That has its own challenges, right? And today we kind of break all these different concerns, right, into different courses. For instance, the model part is so complex that there's a whole course about it, right? If you take databases, right, 3200 or 5200 or whatnot, right? That's all they deal with, right? The model part, how is that you break up the database, so that it's right, it's a correct way of designing the database, yes, right? This course kind of deals with all 3 issues, right? Obviously not in as much detail. I mean, we only cover databases in like 2 weeks, right? Or 3 weeks, yes? But there's a whole course on it if you really want to delve into the intricacies, right? But anyway, yeah, so they came up with that. A lot of the grunt work of the design patterns. .NET built on that and even expanded even further what the design patterns are and best practices and whatnot, right? And then everybody just, each one of these just built on top of that, adding more and more, structure to how is it that you build these large applications? What is the best way of building it? We're going to be using this particular infrastructure, Node.js, right? That is going to allow us to use the JavaScript language, which fits nicely with with what has eventually is becoming more and more prevalent today. Okay. Also on the front end part, on the browser side, again, at first it was just plain old static HTML, right? That's all Tim Berners-Lee cared about, right? But as folks started to interact and they wanted to, what about I want to make a small little game, or maybe I want to see a video, or maybe I want to click and see stuff move, right? And so at first HTML just didn't allow you to do that, right? And so there was a lot of effort at, well, how do we do that? How do we create a user interface that can be interactive with the user, right? It's kind of boring, all this static. And so the first successful solution was Adobe Flash. Right? I don't know if you're old enough to remember Adobe Flash. It became very, very popular where it was an entirely set of languages and objects that were downloaded from the internet, right, and then executed inside of your browser. You had to install a plugin, right, and it was very, very successful. There was an entire industry around Adobe Flash with presentations and games, and very, very successful. In parallel to that, JavaScript, it was a programming language that was already supported by the browser, right? Where you can download an executable JavaScript file and could run inside of the browser. At first, people balked at this and says, "What do you mean? I'm going to download? I have a browser running on my machine. I'm going to go and download an executable and running on my machine? Are you crazy?" Says, "I'm not going to allow you to do that, right? How are you going to go through my file system and look at my personal stuff, right? So I'm not going to allow that, right?" So there's a lot of backlash towards not allowing any of this. Eventually, we were able to, a decade later, we were able to, get beyond that hump, right, of this initial pushback, and JavaScript became a mature set of languages that were matured enough that people started actually building applications around it, right? Now, the language became fragmented, right, with the competition amongst multiple companies, right? IBM and Oracle and Apple and all these different companies saw the importance of creating a browser that people wanted to use, right? And one of the more famous ones is Internet Explorer from Microsoft, right? And so all these companies started to compete, saying, well, we can't be the same browser, right? We have to differentiate ourselves, right? Because some of these companies felt threatened and says, wait a minute. In particular, Microsoft says, if people start building stuff on the web and the only thing you need is a browser, why would you ever buy all the software that I sell you, right? All the Microsoft Word and Excel and PowerPoint, right? That has to run on your machine. Yes, right. Why, if people can go to a Google Sheets and Google Slides and Google Docs, right? And this all runs on the web on a browser. How am I going to sell you stuff that you need to install, physically on your machine, right? That need Windows OS, right? So they felt threatened by the World Wide Web, right? Because it made the operating system irrelevant, right? It doesn't, if everything runs on a browser and you can access and run everything on the cloud, why would you need a particular operating system anymore, right? So they felt threatened by this, and so they started trying to, push a particular browser that kind of broke again from all the other browsers, right? Providing all sorts of features, trying to entice developers, right, to develop specifically for a specific browser, right? Certain features, and it broke with all the other browsers, right? So now developers that were using the JavaScript language, creating applications that run on the browser, found a big problem because the language became segmented, right? If I'm writing a particular piece of source code that that only runs on Safari or only runs on Chrome or only runs on Firefox, right? I'm now I now have multiple different audiences that I need to deal with, right? So it's kind of the same issue that happened with C, right? That when you compile C, right, you have to take into account, well, what is the operating system or what is the architecture that I need to compile this to, right? Yeah, right. And then you need to create all sorts of build files and make files depending on the different, right, on the different architecture that you compile to, right? That you have these libraries or that other library. If you're running on Motorola, you have to do it this way. If you're running on x85, you need to compile this other way. Yes. So the same thing was happening for JavaScript on the multiple browsers, right? So it was becoming very, very hard. So jQuery came along and says, okay, they say, okay, instead of you having to develop to different versions of the JavaScript language on different browsers, right, I'm going to create a veneer, right, a very thin abstraction layer, so that you're going to code to the jQuery API, right, and I will translate down to the different browsers, okay, right, so that you don't have to deal with, oh, am I running on Opera? Am I running on Chrome? Am I running on Safari? Where am I running? You don't have to deal with that. I will figure that out, right? So it created this veneer, this abstraction layer, kind of what Java did, right? Java tried to do this too, right? Where you code once and run everywhere, right? Where it actually became, code once and debug everywhere, right? Where, presumably you don't have to care about the operating system if you code in Java, right? When you compile, the Java C compiler compiles to the correct operating system, right? So jQuery tried to do the same thing for Java, actually copying a lot of the same ideas. So this was the first example of an abstraction layer that virtualized the browser, and on top of that, more and more companies started to take that idea even further. Google came out with one of the larger breakthroughs here, where they took all the best practices that had evolved on the server side from Java and .NET and all these other, these were like a decade earlier, right? And became mature about a decade earlier of what was happening on the browser side, right? So they took a lot of the best practices and ideas from the server side, and then applied it to the browser side. It says, ooh, all these things work well on the server side. Let me copy many of the same ideas over to the browser side. And Angular became very, very popular, a huge success. But they made a very bad strategic error when they went over to the second version of Angular, which was not backwards compatible with their earlier version. So all these companies that had been using and started using Angular, it says, okay, well, now if I want to go version 2, I kind of have to start all over. Right? None of my code that I have, it's useful with version 2. So I'm going to have to rebuild everything for version 2. So they said, they had, well, the heck with that. They says, are there any other solutions out there? And right there, Facebook React was there to, capture all those gruntled Angular users, and React became the one of the more popular solutions that rivaled Angular, and today is still very, very popular. Now this list is ever changing. It's Vue.js is also becoming very, very popular. There's tons and tons of libraries for rendering user interfaces. I encourage you to explore on your own. Other best practices, and we're coming down the pipe. Since there's a lot of things change very, very fast in our industry. Okay. Anyway, oh yes, I did want to discuss this real quick. Right. So the first decade or so in the 2000s, the applications that were being built using .NET and Python and Java and all these were server side rendered, right? Where the browser would request some content, and that request would go out to the server. The server would execute, right, and it would generate dynamic HTML which was then downloaded by the browser. Now, the browser, from the point of view of the browser, this is static text. Right? It doesn't know that this text had been dynamically generated on the server, right? So this is executing on the server, is generating the content, which is dynamic, right? There's for loops and if statements and going out to the database and doing network connections and blah, blah, blah. A lot of computation over here. And then it comes back with some computed static HTML, right? And then it renders here on the server. So this was very, very popular up until mid 2000s, right? Then Google came along and rewrote this. So the current architecture is that most of the content is rendered on the browser, right? We do go out to the server for data, right? Where we query the data, because only the server can go out to some database and networks and whatnot, right? But most of the rendering logic, right, and is run in the browser, JavaScript running on the browser, right? And I think that the biggest distinction, when it became very, very clear to me between these two architecture, the difference between them is when I first used Google Maps, right? I don't know if you remember MapQuest. Anyone remember MapQuest? So MapQuest, obviously it's changed now, right? But way back when, it did basically everything Google Maps does, right? You could search an address, you can zoom in, you can zoom out, left, right, up and down, pan and whatnot. But it was using this technique, right? The user would click on the map or a button to pan right or pan left. Yes, the request would go out to the server. The server would calculate the new map, right? And then it would re-render. It would re-render the entire screen. It was a very jarring interface, but I wasn't aware of it until I started using Google Maps. Right? When the first time you use Google Maps, you don't have that, right? And Google Maps uses this architecture, right? Where you grab the map, right, and you start jiggling it, right, and you can flick it, right, and it automatically fetches the images and it fills in all the empty spaces, right? But there is no jarring re-rendering of the screen. It's entirely smooth, right? You never navigate away, right, and re-render the entire screen, right? You only update small pieces, strategic pieces, right, to make it very much smoother and a much better experience, right? In the Google implementation, you render most of the screen, and depending as the user interacts with the user interface, right, it goes back to the server fetching additional information to fill in the blanks, right? Same thing when you interact with Facebook or any of these user interfaces, right? And you have these infinite scrolls, right? That's what's happening here, right? As you scroll, the client has to go fetch more posts, right? More tweets, more whatever, right? To fill in that infinite scroll, right? It looks completely smooth, but obviously there's a lot of work that's happening here to go out back to the server, fetching more data and filling in that infinite scroll, right? It's the same thing as you navigate between the screens. It's very, very smooth, right? As opposed to using this application. Now, most applications have abandoned this for this application, or in some cases is a combination of the two, right? For instance, whenever you navigate to a first screen, right, Amazon or whatnot, usually it uses this technique, right? It goes out to the server. The server is very, very powerful, okay, and it can compute the response very, very quickly, right? So under half a millisecond or something, right, where it responds and it pumps a lot of content to you, right, and it renders the first screen. But then subsequent queries, as you navigate from one screen to the other or you interact with content, it uses this strategy, right, where it fetches small pieces of content to update the user interface very smoothly. Okay, we're going to be mostly focusing our attention using this architecture, right, which is referred to oftentimes as a single page application, meaning you navigate to a screen and you never leave it. Right? If you go to Google Slides or Google Sheets or whatnot, you're always on the same screen. even though you're navigating and showing different pieces of content, you're always at the same URL. Okay, you never leave it, right? So that's the kind of application we're going to be implementing here. Okay, all right. Okay, let's talk about the first assignment. I did want to cover that. Okay, the first assignment. So as I mentioned earlier, there are, yes. It is, and yes, like Safari is much faster than Chrome and whatnot, and they're always competing. But usually the server makes some optimizations where it pre-computes those or caches a lot of that content, so that there's actually very little computation to be done, right? So it's just mostly pumping content right away from either statistical analysis that it has done from millions of people hitting it, right, and try to guess at what it is that you're going to ask for already, right? And which you can't do on the client. The client is only dealing with you, but the server is receiving requests from millions of people, right? And it can already guess a lot of the stuff that you want to see, or cached it for you so that minimizes all the computation, and it's very fast. It's much faster than what the browser could do. The only bottleneck is the network traffic. Yeah, which is also part of that computation. Where are you? So do I know where to compute this? Yeah. All right. So yeah, as I mentioned earlier, there's going to be 6 assignments, and all assignments are laid out in the same way. There's 3 portions to each assignment, right? The first part is labs, right, where we ask you to go through several exercises, right, that are fairly unrelated to each other, right, where we are going to illustrate a particular set of skills, right, that and each exercise is meant for understanding that particular skill, right, and independent of other skills. Then in the second part is the Canvas section, where we ask you to say, okay, well, now that you learned about these skills, use those skills to build this. Okay, so in the Canvas application, we ask you to build a few screens, and that you can navigate between a couple of screens. And then there's a third section that doesn't relate to you, right? That's the graduates a part that is meant for only graduate students. So we ask them to do some other stuff additional. You're welcome to play with that as well if you want, but it's not required, right? We're not gonna grade you about the grades part, all right? So each section is worth the same. So 50 points for the labs, 50 points for the Canvas side, right? So the labs, the first couple of labs ask you to set up a development environment, right? And they ask you to download Node.js, right? Install Node.js, then create an application, and I guess I could demonstrate. So let's see. Let's see. New. And let's see, 2023. And let's go to fall. Okay. So in the fall directory, we ask you to create maybe a directory for your particular section. So this would be 4550. I think this is section 2, right? I think. And in here, we ask you to to create your first application. So after you install Node.js is basically just a JavaScript interpreter, right? It allows you to code using the JavaScript language, and usually JavaScript language is understood as a language that is meant to execute inside of a browser, right? And what Node.js allows you to do is to break out JavaScript from its browser container so that you can just have a JavaScript file and run it right from the command line. That's all Node.js is, right? It's a JavaScript interpreter so you can run JavaScript code on the command line. That's all it is. And once you install Node.js, it installs 3 executables of interest, right? The Node interpreter that allows you to give it a JavaScript file and then run that JavaScript file on the command line. An NPM, right, which means a Node package manager, right, which allows you to install libraries, right? So go out to a repository, a code repository, a very popular code repository, npm JS. So npm JS is a repository of libraries that folks have been making available for free, right? Most of them are open source, right? And I encourage you to create your own libraries and post them here. It'd be great for your resume of how many folks are using your particular library, how many downloads and whatnot, right? And one of the libraries that we're going to be using is the Create React App application, right? Which is created by Facebook. And you use the npm command line command tool, which is part of the Node.js installation, to install these libraries, right? And this is how you would run it to install it. Okay. Now, the third executable is what we're going to be using, which is npx, which is it's a combination of npm, which downloads the library, but then it executes the library right away, right? It doesn't keep it around. Right? It downloads the library and execute it right away, right? So this is going to download Create React App, and you can give it a command, the name of the application that you want to create, right? And that's exactly what we're going to do. We're going to copy that, and we're going to paste it here. I'm going to give it just a different name. Create React Web App. I'm just going to give it a CS4550 just so that I can distinguish from different sections. So let's do that. So yeah, so that's going to download the Create React application, and it's going to execute it and create a local web application called Canvas React Web App. Okay, so let's leave that for a second. So this is using the React library that I mentioned earlier, which has been competing with Angular and many other libraries, and it's still one of the more popular libraries that allow you to create user interfaces, right? So again, the first half of the semester, we're going to focus on creating the user interface part of the application, right? And the application, remember, has 3 pieces: the user interface, which is going to be this, right? Then the second half of the semester, we're going to focus on the server side of this, right? And so we're going to create another project, but it's going to be called, the Canvas Node Server application, right? And it's going to be its own project, right? And we're going to have to integrate those two together, right? But we're going to focus on the user interface first half of the semester, which is a React application. It's a React web application. React also has a mobile version, right? That you can use the same exact skill set, right? That we're going to be covering this semester, right? To implement mobile applications, right? That you can build, iOS applications, Android applications, right? That run natively on your phones or tablets, which is pretty cool, right? So the same skill set that we're going to be learning this semester is now applicable as well to build mobile applications. Okay? Anyway, that's going to take a while. Let's go back to the assignment. So while that's going, And we're going to ask you to learn about various HTML elements that allow you to build a user interface. We'll talk about just a few simple things like creating headings and creating just simple paragraphs, some really trivial stuff, right? And most of this is asking you to copy and paste the code, right, in a file, and then verify that it renders as we say it renders. Yes, right. So the lab is very hand-holding, right? We're going to hand-hold you throughout the labs. Do this, verify that it does this, do this, and so on and so forth, right? And so learning about creating lists, like creating tables, creating images, how to render images, how to render form elements like input fields, drop downs, dates, and sliders, and numbers, emails, phones, things like that, right? All sorts of elements and text areas, buttons, drop downs, just form elements, lots of form elements. How to do check boxes and radio buttons, and also how to navigate between multiple screens. Right, we'll ask you to create a couple of documents and then implement hyperlinks that navigate between the screens. Okay, so now that you'll be familiar with the basic skill set, right, of HTML and creating contents, we ask you, okay, well, now that you've gone through that, build something from scratch, right? We give you canvas, right? And we say, okay, well, now that you've practiced how to do HTML, let's build the Canvas learning management system. And we ask you, well, let's implement the home screen, right? And the home screen is something that looks like this. It's got multiple columns, right? So it's got 1, 2, 3, 4 columns. Well, we've done tables, right? So maybe we could do, a table that has 4 columns, right? And you can set the width of the columns. We know how to make hyperlinks, right? Because we just learned how to do hyperlinks. Now, it doesn't have to look like this. It doesn't have to look pretty like this, right? We'll do that in the second assignment, right? This first assignment, we're going to focus on just the content, right, and the basic layout of the page, right? And it's going to look awful. It's not going to look like anything like this, right? It's going to look ugly. None of these buttons actually have to work, right? In the second assignment, we're going to come back and say, I'm going to paint a little bit, right? We're going to change the background to be black, the fonts to be a little bit prettier, right? And how to change the borders here and make it green, and how to add all these icons, pretty icons of different colors, right? So that's going to be the second assignment, but still static. In the third assignment, we'll come back and say, okay, well, I want to be able to drag this around, or I want to add a new module, or I want to delete a module, or I want to change the order of these modules, right? Or I want to go to my account, my profile, and change my email or my phone or my whatever. Yes, we're going to learn how to do things dynamic. Also, instead of making it static, hey, let's create a JSON object that's an array of modules that's going to live in a separate JSON file. It's going to load that, and they're going to dynamically render this, right, from data. Yes, right. And so we're going to progress across multiple assignments, tackling, each piece as we go, right? And then well, how do and then want to be able to share the data across multiple, as you navigate, you want to be able to see the different parts. We're going to learn how about maintaining state and the server side and logging in and whatnot. Yes. So the home screen, we present you that this is where we're going, but what you're actually going to build is something that looks very ugly, right? Which is most of that content, but it doesn't look pretty, right? It just has content, just a text. It's got the hyperlinks. They are lists, right? The weeks are lists that contain other lists. Some of them are hyperlinks, right? And some of them are buttons. Some of them are drop downs. Yes, right. So that's what your output should look like. we'll come back next assignment to make this look pretty, right? And also all these hyperlinks, most of these hyperlinks don't do anything. The only ones that really need to work are grades, because we're going to ask you to implement the grades screen. The assignments hyperlink, because we're going to ask you to implement the assignments screen. And the home screen, because we're going to ask you to implement the home screen. None of the other links need to work, right? They can be, left open and ignored. Okay. I don't forget. I forget if I ask you to link these to actual slides. I forget. I don't remember. None of these have to actually do anything. Some of these drop downs, I don't even tell you what's under there. So it's fine if it just has just that one option. Okay. Then the grade screen, this is where we're going, right? Eventually. But for now, it'll just be, just a ugly text, ugly table with some assignments. I ask you to do at least 4 assignments and 4 users. Yes, at least. And you can make up the grades and the names of the assignments. You can change that, right? Again, this is to practice on how to use tables and input fields and buttons and drop downs, right? So just some practice there. Then the assignment screen, this is where we're going, right? But for this assignment, you're gonna just, again, focus just mostly on the content, right? Again, hyperlinks and the different assignments and links to those assignments, a couple of drop downs and whatnot, right? And then now when you click on a particular assignment, it goes to the edit assignment, right? That allows you to edit the assignment. Not really, right? Because we don't know how to do that yet, right? Right? It goes out to a form that allows you to presumably change the name of the assignment, change how many points, whether it can be how it can be submitted, when it's the due date, right? Again, all this is static. It doesn't actually have to work, right? All this is for you to practice how to do forms in text area. And I'll do some of this for you. I'll get you going, right? Get you started on a lot of this. We'll do it together, starting Monday. And we'll start working on this Monday. We'll work on the profile screen, right? That allows you to navigate to your profile and change your profile, your biography. So here's what you have to implement, right, in the editor, and that's it. Okay. Yeah. So basically, the home screen, the grade screen, the assignment, and the profile. And we'll get started. Get you started going on Monday. Graduate students are asked to do a few other things. You can ignore that. Now, for your submission, your submission consists of putting all this in a source control, right? Committing all your code in source control, posting it on GitHub, right? And then sharing with us the link where the repository lives. Okay, each assignment is going to be submitted in a particular branch, right? So each assignment will have the A1 branch, the A2 branch, the A3 branch. Each assignment will have its own branch. Okay, and you will deploy this to a server, right? So this walks you through creating the Git repository, adding your code, committing your code, and then deploying it to a server. So we're going to be using Netlify to host our web application. We're going to push all our source code and it's going to deploy to Netlify, right? So that your application don't just run on your local machine, it runs in a remote public machine so that everybody can see your work, right? And you will submit the URL to that repository as part of your submission, right? So that TAs can then navigate to that server and verify that this is actually running, okay? All right, so yeah, the deliverables, we need those 2 links. The links to your GitHub repository and your link to this running on Netlify. right? That's what you're going to submit to us, right? So anyway, so I think now this should be done. Okay, so it's done. Our application is done, and we'll see that there's a directory for the Canvas React web app. And if we go in there, we can do an npm start. So this is going to compile the application, and it's going to run it. And it looks like already we're using 3000. And it's going to bring up the application in a local browser, right? Running at localhost. Typically it would be 3000, but I guess I had already something running on 3000. And so this is the default web application that is it's kind of like a boilerplate web application that is already optimized, already is implementing lots of best practices. It already is ready for you to do testing. It's already has all the best things already implemented, right? It would take you a couple hours to set this up on your own from scratch, right? But Facebook has created this tool which gets you going right away. And we can open it up with our favorite IDE. So we can say open, and we can navigate there. Public 2013, fall. And here, it's this one. We can open it up. Okay. Yeah. So what was being rendered here is it all inside of this source directory. The source directory includes all the source that we're going to be mostly working on this semester. Now, this is when we start working with React.js, which won't be for a couple of weeks, right? For this assignment, we're going to be mostly working under our public directory, okay? So we're going to have to just break a few things here for you to be working on the public directory. But for now, let me just introduce to you what a React application looks like. Basically, the entry point to any application is this index file, index.html, right? And this is HTML, this is plain old HTML, right? And the content in here is just this one single entry here that says root, okay? And what the magic happens is here in our JavaScript, grabs that root content, and it injects the content of what's inside of this app here, right? And this is where you see this edit here, edit, where you see this hyperlink that allows you to click and go learn more, right? Where you have this image, right? Render this spinning image, right? So this is where the content is happening here, right? We're not going to be talking about the details of this for another couple of weeks, right? So if you don't understand it, that's fine. We'll come back to this in quite a bit of details. I just wanted to just show you real quick of where that content comes from. Most of what we're going to be doing is under the public directory. So I'm just going to break this for now. Just break this. So it's broken. And I'm going to be focusing our focus on here in the HTML index.html. This index.html is where we're going to be spending most of our time. Welcome. Can I spell here? Welcome to web dev. Okay, welcome to web dev, right? So we're going to be spending most of our time inside of this public directory in this index.html, right? And we're going to create all sorts of other HTML documents. And we're going to learn about HTML. Once we learn about HTML enough, then we'll be ready to move on to more interesting stuff, such as the JavaScript stuff and dynamic stuff and whatnot. All right? Okay. Okay. So the first couple of assignments ask you to create a couple of folders in here where you can work on your labs in the labs folder, and Canvas in a separate folder, right, where you can work on the second half of the assignment under Canvas, right? In the labs, you're going to have a whole bunch of labs throughout the semester. Work on the A1 lab for the first assignment, and then you're going to have A2, A3, right? So in each assignment, you're going to have a different directory that has all the source code for that particular assignment. Yes, right? And so in each assignment, you're going to have a separate file, index.html, where you're going to introduce and start working on that particular lab, right? So you're going to have, this is lab 1, right? And each one is going to have its own index file, where you're going to have lab 2, right, and so on and so forth. And in the root file, in the root index.html, we're going to create hyperlinks to these various documents. Right? So we're going to create a hyperlink that's going to allow us to navigate to the labs inside of A1, inside of the index file. Oops, can't type. There we go. So this is lab 1. So there is lab 1, and if I click on lab 1, it allows me to navigate down to lab 1, yes? And inside of lab 1 is where you're going to start implementing all the things that we ask you to do, right? So for instance, the first thing that we ask you to do is to work on learning about headings, right? Which we already did, right? We already did some headings. H1 says render this in a big heading, right? With our biggest heading. Right, and so one of the things that you're going to learn about is multiple sizes of headings. So H2, this is a smaller heading, right? So this is a smaller heading. So H1, H2, H3 get increasingly smaller and smaller heading. That makes sense, right? And once you're done, you're going to be asked to commit this, right, and create a source control repository in Git. You say GitHub, and you're going to go to your repositories. You create a new repository, and your repository should have the same name as the folder. So if you copy that, right, you can create that. And you can leave it as public, right? And then you're going to commit your content in your repository. So it looks like I have a couple of source code in here. We can add everything. First commit, and we're going to push this to our remote repository. We're going to copy that. We're going to add that repository I just created on GitHub. I'm going to add it to my local repository, and then I can push all my content, right? And now if I refresh the screen, I can see all the source code that I had locally on my file system. It's now available remotely, right, for anybody to see. Okay, so this is one of the things that you're going to submit to us as your deliverable in your first assignment, right? And this is in branch main. I made a mistake. It shouldn't be in branch main. It should be in branch A2. So we should have checked out, created a branch A1. Push. So this is pushing it to branch A1. A1, there it is, A1. So this branch A1 is what you would submit, right? And then for assignment 2, you would have branch A2. And then for assignment 3, you will have branch A3, and so on and so forth. Make sense? Right? This is going to allow you to keep working on the next assignment without having to wait for the previous assignment to be graded. Make sense? So the TAs are going to be able to look at the multiple versions and grade you accordingly. Make sense? All right, excellent. Thank you. Oh, I'm sorry.
A startup on campus. If you are an exceptional front-end engineer looking to work, you will continue with other great engineers hiring. So please reach out to